Hey YouTube, this is Brendan Cusack, and we're here with a video on how to do inscribed volume word problems. So we're only going to talk about one case in this video, and then I will challenge you to try to draw some of the other cases, because it is pretty difficult to set up. But to find additional images for those cases, I'd recommend just Googling things like cylinder inside of a sphere, or cylinder inside of a cube, so on and so forth. So what we have right here is we have an image produced by Wolfram Alpha. So for those of you who don't know what Wolfram Alpha is, highly suggest you check it out. It's a great little resource for solving math problems. And what we can see here is that we have a sphere that is inscribed inside of a cube. Now, it's very hard to draw these, so much easier to kind of work from an image, and they typically will provide you with an image on the SAT. But what we can see here is if I were to draw the diameter of this sphere, is that it's equal to a side length of this cube. It's a little hard to see from the angle, but essentially these two lengths should be the same as each other. So we have the case where diameter of sphere is equal to side length of cube. So a question on the SAT related to this might ask you something along the lines of how large of a sphere can fit inside of a cube with a volume of 125 meters cubed. And we're trying to figure out what's the maximum sphere that can fit inside of a cube with that volume. Well, if we go ahead and we think about it a little bit, if the volume of the cube is 125 meters cubed, the volume of a cube is equal to length times width times height, as presented on the SAT, which is essentially side cubed because all the sides are the same. So we could say 125 is equal to side cubed. And that would tell us the side of the cube, each side, is going to be 5 meters. Now, if the side of each cube is 5 meters, we know that the diameter of the sphere is also 5 meters, which would mean that the radius of the sphere is going to be half of that, or 2.5 meters. So if the radius of the sphere is 2.5 meters, we know the volume of the sphere is 4/3 times pi times r cubed. And instead of 2.5, I'm going to do 5 halves because sometimes it's a little easier to work with fractions. So this would be 4/3 times pi. 5 cubed is 125/8. I can cross simplify. That becomes a 1 and that becomes a 2. And so this becomes 125 pi divided by 6 meters cubed. So that's a common question. Not super common, but it's definitely one that people have a very high probability of missing if it were to show up. So they may ask you about a sphere inside of a cube, or they may ask you about a cube inside of a sphere. They could also ask you questions about cylinders inside of spheres, cylinders inside of cubes inside of cylinders, so on and so forth. So I think that's it. That pretty much describes the kinds of questions that you're typically going to see related to this type of problem. Thanks for watching.